talking about the negative exponent law, what we're going to want to do first is talk about decimal forms. So if you use your calculator to determine a few different things, for example, 1 to the power of negative 1 is 1. I'll give you a little bit of help with the fractions. It's 1 over 1. If you type in 2 to the power of negative 1, though, you get 0.5. 3 to the power of negative 1 is 0.3 repeated. 4 to the power of negative 1 is 0.25. If you still haven't gotten those numbers, make sure that you're able to get those numbers as decimals. Being able to use those negative exponents is going to be quite necessary for this. 5 to the power of negative 1 is 0.2. 6 to the power of negative 1 is 0.16 repeated, only the 6 being repeated. And 7 to the power of negative 1 is 0.14285714287. It's really, actually, I'll write down the decimals. For your calculators will have a 3, but really it is 28, which means it is actually 0.142857 repeated. So where does that tie into our fractions? Well, 0.5 as a fraction is 1 over 2. 0.3 repeated as a fraction is 1 over 3. 0.25 is 1/4. Maybe you can see the pattern already. 0.2 is 1/5. 0.166666 is 1/6. And the last one is going to be 1/763rd. No, I'm just kidding. It's 1/7. What we're doing is we're taking the reciprocal. The reciprocal is just the numerator denominator switched. Each of these numbers are all over 1. All we're doing is taking the reciprocal of these base numbers. That's it. Absolutely, that changes if our number is not -1. -1 works great. Ours 1 really do work out fantastic. It's what happens when we have numbers that are not -1, like -2. If we were to type in 5 to the power of -2 into our calculator, what is that? -2. We get 0.04. So it doesn't, that means that our number of 5 to the power of -2, well, what we're doing is we're not just taking the reciprocal and just writing 1/5. 1/5 is 0.2. At the same time, 0.04, it's actually 0.2 squared, which means this entire thing is actually being squared. And if we use our exponent laws, that exponent on the outside gets distributed onto each base on the inside when we're dividing. We'd have 1 squared over 5 squared. At the same time, realizing 1 squared is kind of redundant. Absolutely, yes, at the same time, it's 1 over 25. But what this is really meaning is helping us to tie in a new exponent law. We've done the 6 in grade 9. We did 1 more when we dealt with our fractions, and now we're going to deal with negatives. If you have a negative exponent all we're going to do is take the reciprocal of the base. If our number is different than -1, so let's put it all together. The negative takes the reciprocal of the base. And the negative is removed. Which means as soon as we take this reciprocal, only the negative is gone. We've taken this 5/1 to become 1/5, the negative is gone. Then we have to go to our other exponent laws. For example, this power of a quotient means that we have to distribute our exponent onto the numerator and onto the denominator. So let's do some work here. 4 to the power of -3. Well, 4 is the same as 4/1, which means that as soon as we see that negative, what we're going to do is we're going to take the reciprocal of our base. Instead of 4, it's going to be 1/4. But that's going to eliminate that negative here. One thing apparently I do need to say is it does not become this. You don't take the reciprocal or you don't do this. Both of these are so very wrong. The negative only takes the reciprocal of the base, or converts our base into its reciprocal. After that, then we can distribute our exponent onto the numerator and denominator. 1 cubed and 4 cubed. 1 cubed being 1 and 4 cubed being 64. Just be careful. Some people have done this. Don't be the one that does it. 2/3 the power of -2. Well, that means we're dealing with a negative exponent. As soon as we see that negative exponent, we're going to take the reciprocal of our base. So that 2/3 is becoming a 3/2. All that this does is get rid of the negative here. It's still going to be squared, which means we're going to distribute that squared onto the numerator and onto the denominator. Oh, sorry, I'm writing down the answer before. Three squared, 9, 2 squared is 4. Yes, if you type 2/3 into your 2/3 power of -2, you'll get 2.25. But if you have the option to use fractions, use the fractions. Show your work, show that you can do it. Show me that you can do it. Last one. Now here's something that's a little more fancy with a negative number. Well, as soon as you have a negative number, attach your negative to your numerator or to your denominator. It does not matter which one, just as long as it is only 1. I know that some of you are able to just go from right here right to your next step. That's perfectly fine. I'm just showing it just so it's completely visible. That negative exponent, well, that means I'm going to take the reciprocal of my base. The exponent just becomes a positive then. I go further. 3 cubed. -10 cubed. And I go further. 3 cubed is 27. -10 cubed is negative 1,000. It's fine if you put it here at the same time. I'd probably prefer that you either put it in the numerator or in front. Just as we've discussed already, either last year or this year. We've talked about those negatives. It can be in the numerator, it can be in the denominator, it can be in front. Ideally, it's numerator or front. So let's do a little bit of combination of our last two sections. This section and the last one. Evaluate this using powers. So again, you're going to use your powers. If you just type this into your calculator and just get the answer, well, you're not doing your work. You're not showing me that you actually know how to use your exponent laws, which means I can't give you credit. I can't say that you've actually mastered these skills. You have to know how to use your exponent laws. 9 to the power of negative 3 hows. Well, 9 is the same as 9 over 1, which means I have 1/9 to the power of 3 over 2. Well, if we remember back to our previous section, sorry, actually, before we get to that, let's apply our exponent onto the numerator and onto the denominator. 1 to the power of 3 over 2 and 9 to the power of 3 over 2. Now we can tie back to our previous section where we talked about, let's see how far, yeah, I got lots of space. The denominator of our numerator or of our fractional exponent goes into denotch. The numerator is the power. Denominator goes into notch. Numerator is just the exponent. Of course, this could be just as well written with that numerator exponent on the outside. Your answers are going to be the exact same no matter what. 1 cubed is 1. 9 cubed, don't really deal with that one a lot. I'm dealing with the square root of 729. Or if I go the other way, square root of 1 is 1. Square root of 9 is 3. On this side, I deal square root of 1. Well, the answer is going to be 1. Square root of 729, just double check, it should be 27. It is. Or on this side, 1 cubed is 1, 3 cubed is 27. Answer comes out, same, doing it either way. You stick with something that you're most comfortable with, but at the same time, being conscious of the fact that there is another way of doing it. One of my favorite ones, especially since I did indicate that these two are really nice numbers to work with. Negative exponent, I'm going to take the reciprocal of that base. 64 over 27 to the power of 2/3. So then I have to apply my exponent onto the numerator and onto the denominator. One thing, let's see, I talked about it a little bit more last year in grade 9 than this one, but here's another way that we can work with this. So I'll still write this out. I'd have 64 to the power of 2/3 and 27 to the power of 2/3. At the same time, I could treat all of this as being all with the cube root of all of that squared. So meaning I could technically do this another way. Because denominator still goes into the notch, the numerator is still the power. The only difference is it's going to look a little bit different. So I'll show this one both ways again. I'll finish off this one and then I'll work on this right-hand side. So cube root of 64, and actually I like this one to do it this way. Again, or not again, just for the fact that I'm more comfortable with it, and I know that it works out nicely. The cube root of 64 is 4, so 4 squared. The cube root of 27 is 3, 3 squared. 4 squared is 16, 3 squared is 9. If you just type this in your calculator and you get 1.77777777, you haven't shown me that you know how to use this, which means I can't give you any credit for it. Whereas this one, I know that some people are able to do some work without having to show everything, but you still need to show some steps in order to get credit. If you skip from here and get right down to the answer, well, that means that you just type in your calculator, and that's not actually showing any of the skills. It's not showing mastery. I could apply I don't have to necessarily write 64 squared and 27 squared. I can just know that I have to apply my squared onto both. 64 squared being 4,096, 27 squared, 729. And then the cube root. Well, the cube root of a fraction does actually mean I'm taking the cube root of 4,096 and the cube root of 729. This is a concept that we've done in grade 9 about having the square root of something. For example, we had done questions like what was it, the square root of 81 over 4. Well, it's taking the square root of 81 over the square root of 4 and getting 9 halves. It's the same thing. We did do it last year. If you didn't, it's not the end of the world as long as you're able to follow along now. The cube root of 4,096, 16. The cube root of 729 is 9. Both answers, the exact same. And you can go have some fun.